Consider an underground water source whose free surface is 60 meters below the ground level. The water is to be raised 500 meters above the ground by a pump. The diameter of the pipe is 10 centimeter at the inlet of 15 centimeter at the exit, neglecting any heat interaction with the surroundings of frictional heating effects. Determine the power input to the pump required for steady flow of work at a rate of 15 liter per second. So you have the given D2 is equals to 15 centimeter, D1 10 centimeter. The Z1 is equals to 0. The Z2, which is 60 meter plus 5 meter, is equals to 65 meters. And the V2, which is 0.015 meter cubic meter per second, from the 15 liter per second. So converted 15 to cubic meter per second. And our equation here is Q is equals to the change of potential energy plus the change of K plus the change of U plus the change of the workflow and plus the hour work. As we see in the problem, our Q is 0, so cancel out the Q. And our change of U, internal energy, is equals to 0. And same here in the workflow. So now our work is equals to the negative potential energy minus the kinetic energy, change of the kinetic energy. And to find the AP, the change of potential energy, is equals to mg times the change of our height, or z. And as we all know that change of z is equals to z2 plus our z1, which is z2, which is 65 meters plus 0 meters, equals to our change of the height is 65 meters. And we have to find the change of our mass. So our mass is the density times the velocity, which is our density of the water is equals to 1000 kilogram cubic meter, and our velocity is given is 0.015 times our velocity, which is 0.015 cubic meter per second, and our mass here is, or cancel our cubic meter, so our mass is 15 kilogram per second. So we have now our mass and our change of the height, so we can find our change of P, our potential energy, mg times our change of z, or change of height, is equals to the mass, which is 15 kilogram per second, times our gravity, which is 9.8 meter per second squared, times our z, 65 meter, is equals to our change of P is equals to the 9,555 kilogram per second. So let's go now to find our change of kinetic energy. The change of kinetic energy is equals to V2 squared minus the V1 squared all over 2 times our mass. So we have our V2, our V1 to, you have to find out our V2 and V1. So V1 is equals to our V1 here is equals to the M1 over the density 1 and our area, which is the pi d1 squared all over 4. So 15 kilogram per second time over the 1000 density, because our P1 and P2 is the same, is equal. So 1000 kilogram per cubic meter. Kilogram per cubic meter times the area, which is D1. Our D1, we converted the D1 into meter. So 0.1 or 0.10 squared all over 4, and the result of our V1 is equals to 1.910 meter per second. And to find our V2 is the same. V2 M2 rather, is equals to the density 2 times our area. Our M1 and M2 is equal, so the same mass, 15 kilogram per second, times our density 2, which is the same, 1000 kilogram per cubic meter, times our area, which is pi times our D2, which is 15 centimeter, converted into meter. So 0.15 meter squared all over 4. So our V2 will be negative 21, sorry, 0.8 our V2 is 0.849 is 0 meter per second. And to find our work, so to find our K is equals to, substitute our V2, which is 0.849 squared, minus our V1, which is 1.910 meter per second, all over 2 times our mass, which is 15 kilogram per second. So cancel the unit, meter per second, and our change of K will be negative 21.955 kilogram per second. And to find our work, which is the change of P, a negative change of potential energy minus the change of the kinetic energy, which is our change of potential energy is equals to 9,555 kilogram per second minus our change of the kinetic energy, which is negative 21.955 kilogram per second. So our work now is 9,533 kilogram per second, or 9,533 kilowatts. 9,533 kilowatts. That's all.